And are we, come on, we're live, cool. Okay, so here's what we did. We have a piece of paper, and it has 4 square corners cut out. So to make, oh well, Tom, whatever. So let me start with just a picture, okay? So we did in class a sheet of paper, like a regular sheet of paper, which was 21.5 centimeters by 28, okay? And then what we did is we cut out squares. So this time we're going to cut out arbitrary squares. Call it X, because we want to find out the best cut. Does that make sense? X, the unknown. We don't know. What is the best cut? Let's call it X. We don't know. Okay, we're going to cut out the X's here and here, here and here, here and here, okay? So then we cut out those corners and we make a box. So let me draw the box 3-dimensionally. See how good you guys are at drawing boxes. A lot of kids have a really hard time doing this. There's my box, right? 3-dimensionally, okay? So what happens is that the length of this box is no longer 28, but it's 28 minus the 2 cuts, right? That makes sense. And the width of the box is no longer 21, but it's 21.5 minus the 2 cuts, right? Because we throw out the cuts. The length of the box has changed. And then the height of the box is the fold. It folds up, or the length of the cut. Okay? We know volume is going to be, and I'm going to go V of X, volume with respect to the cut, is equal to length times width times height. So I'll go X times a 21.5 minus 2X times a 28 minus 2X. Okay? Now, since it's a cubic, we don't have a fancy little formula, so we're going to have to graph it. So we could probably put it on Desmos, right? Let's check it out on Desmos. School Desmos. And I'm not going to multiply this out. I'm not. I'm going to leave it just like that. It's much easier to put in my calculator if I just leave it like y equals, and I'm going to go x, and I'm going to go parentheses. I'm going to go 21.5 subtract 2x, right? Times another 28 minus 2x. Okay, now, the box is so big that I can't see all of it. That's okay. I'll just make my calculator. I'm going to find it, right? Okay. All right. All right, I'm still trying to find it. I'm going to get it. I'm going to get it. I'm going to get it. It's a big box, huh? Look at that. But we knew what was our volume? 800? 900. So I got to go quite a bit more, huh? Right? Got to get up to 900. Come on. Come on. I'm getting there. All right. Did you get it?
About 4.04. I don't have, like, it won't let me go to the exact vertex, but.
Okay. You already got it, huh? Did you put it on a graphics calculator? I normally would have put it in a graphics calculator, but everybody likes Desmos, so I'm just going to do Desmos. Oh, come on. I got to be getting close. I'm at 800, right?
Zoom out more.
Oh, yeah. Wow. Come on. Where's that vertex? Wow. Oh, I'm getting close. There it is. Oh, there's my vertex. Boom. Okay, there it is. So 4.02. Okay, so here's what I know. My x value is 4.02. My y value is 1080.02. Okay, so the dimensions are going to be, for the volume, is going to be a 4.02 by, okay, well, I'm going to plug my 4.02 into here and into here to get my length and my width, right? Okay, so I'm just going to go, okay, 28. I'll go 21.5 minus 2 times my 4.02. And I get my width, 13.46. And to get the length, I'll put my 4.02 in there. I'll go 28 minus 2 times my 4.02, and I get an answer of about 19.96. Okay, awesome. So what's my volume? Well, according to this, it was 1,080.02, and that's in terms of centimeters cubed. Okay, thumbs up so far? Okay, not bad. It's always nice to build the box because then you really know what I'm doing, right? Okay, now, what's the domain? Well, the domain, we did it. The domain is the cut. The domain's always the x. The domain is the cut, right? And the smallest cut we can make, and Evie, you made a pretty small one, but you could do it smaller, right? You could. So the smallest cut has to be just bigger than 0. And the largest cut, would you guys say half of the 21? It's got to be half of the largest cut. It's going to be half of the 21.5. What'd you get? 10.75. Okay, so the domain is 0 to a 10.75 centimeters, right? Okay, not bad. Everybody with me? Okay, because if I cut more than that, then there's no box. It just disappears. Okay, the range, of course, is the volume, right? Range is the y, but in this case, it's the volume. So the smallest volume is 0. You guys agree with that? 0. Smallest volume is 0. And then the largest volume was our 1,080.02, right? Okay, that's not so bad, right? Now, ignore this, okay? We're not doing this, okay? Because we already did some of that, okay? Now, thumbs up. Okay, now, let's go to the second, or example 3, okay? So, we could take a piece of paper. This one says we can adjust the shape, okay? So, rectangular piece of paper, these manufactured with perimeter tuners. Well, it doesn't have to be this. We can change it. We can make it a different shape, as long as it has perimeter tuner, okay? And then what we do is we're going to fold it up to make a box, okay? So I'm going to fold like this. Right? This is what we want to make. You see it? What we want to make, okay? So this is a set volume. This is a set perimeter, but I could have a different size piece of paper. One is perimeter 200, okay? So let's just draw a picture of what we're going to do, okay? So I'm going to take a piece of paper. Oh, Landon. He's going to end up with a full ride at PLU, and he's not going to want to go to PLU, but it's like tough. How can you complain, right? So let's take a look at this one. So if I have a rectangular piece of paper, I'm going to fold. Right? So I don't know how big I want to make these folds because I can adjust this paper. I mean, just for example, I could have the same piece of paper could be shaped maybe like this, just hypothetically, right? Or the piece of paper could be shaped even like this, hypothetically, right? So we don't know the shape of the paper, we just know the perimeter has to equal 200, right? So what I want to do is, I'm not sure how big these are, but I need a fold here, 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 and here. And they all have to be equal because I'm going to try and make a rectangular prism, okay? So they have to be equal for this to work, which also means that it have some length from the original perimeter taken here, some length from the perimeter taken here. So what's left over for the sides? Well, the perimeter is 200. But the perimeter is going to be, we're going to have to take away 8 x's. So we're going to go 200 minus 8x is left over for the two sides. Okay, are you with me? I'm going to put, maybe it's 10, 10, 10, 10, 10, 10, 10, 10. What's left over can go here and here, correct? So I subtracted out my 8 x's, but then I need to divide that by 2. So I have length here and here. Okay, so if I divide that by 2, I'll have a 100 minus 4x. And I'll have a 100 minus 4x, okay? So then, let's build a box. Okay, so if I build a box, the box is going to look something like this. Right? X, 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 and then 100 minus 4x, okay? How am I doing? Am I going too fast? You seeing it? So volume, we want to maximize the volume. So the volume is length times width times, in this case, depth. Okay, so we'll go x times a 100 minus 4x, okay? Or v of x, volume with respect to the cut, x squared times 100 minus 4x, okay? Jack, I'm going to use my graphics calculator this time. It's just faster for me to use a graphics calculator, guys. So y equals, it's on plots. Hold on, let me go on another calculator. I'm going to just put it on my calculator. You guys can put it on Desmos. I'm much better with a calculator. So I'm going to go x squared times 100 minus 4x. Graph, I might have to change, oh yeah, I'm going to change my window. So I'm going to go much higher. My domain's good on my calculator, but my window, I'm going to go to my YMax, and I'll probably try 2,000. Let's see what happens. Oh, 2,000 wasn't even big enough. Window. Okay, let's try 10,000. So reach for the moon, huh? There we go. Okay, so the very best volume is at the top, at the vertex. Well, actually, it's not really a vertex, but at the max. So, second, calculate maximum. I know, if everybody had a calculator, I could show you how these are amazing calculators. Yeah, 16 and 2/3, right? Perfect. So here's what we know. That the x is 16.6 repeating, or 16 and 2/3, same number, right? And the volume is at 9,250, about 59 centimeters cubed, okay? Domain. Domain's tricky. Domain. Anybody need to figure out domain? I know it, but does anybody have any ideas on domain? Domain's the x, right? So we know for sure that the domain are these folds, right? So these could be almost 0, and then your thing would be super skinny. I mean, if we could have like something that looks like this. All right, then we'd have our folds, and then we'd make Evie put it together, right, Evie? We'd have you build that one. So our domain could be as small as 0 for each individual side here, right? But the largest it could be is 25. Now, where did I get the 25 from? Yes, so I'm saying it's 25 because if this is 25, 25, 25, 25, if it was, the length of this would have to be 100, right? And if I went 25, 25, 25, 25, the length of this would be 100. 100 is 200. I wouldn't have any perimeter left for the sides. Does that make sense? How did I get that so quick? Well, I knew I had 8 x's, right? And so I knew I had to take all 8 x's and consume the volume, so I divided this by 8, and I got 25. That's how I did it so quickly. Okay, what do you guys think? Thumbs up? Okay, all right, let me go ahead and stop my recording. And the homework is very similar to this.